Okay, we recently talked about tangential acceleration, okay? We called it A sub t for tangential acceleration. And that had to do with when an object was speeding up or slowing down. Okay? By the beginning of the year, we said that an object could be accelerating in three different ways. They could be speeding up, they could be slowing down, or they could be changing direction. So even if an object is moving around in a circular path at a constant speed, they're still accelerating. We use a different type of acceleration to describe that, and we call that the centripetal acceleration, or A sub c, C for centripetal, and that is when it is changing direction. Okay, so let's go ahead and just look at some examples about this centripetal acceleration. Okay, so imagine that you're in a car and you are at a stoplight and the light turns green and you decide to speed up very quickly. Okay, while you're in that car and you're speeding up very quickly, you are going to be pushed back into your seat. Okay, you're going to move backwards a little bit. You're going to feel that. Okay, now you are accelerating to the right, okay, and you are moving backwards a little bit. Okay, then let's look at another example. This time you're at the stoplight, or you're not the stoplight, you're coming towards the stoplight, and you slam on your brakes. Okay, now your acceleration is going to be in the opposite direction because you're slowing down, so it's the opposite direction you're moving. So if you're moving to the right, the acceleration is going to be to the left. Okay, and you are going to feel like you are going to be moving forward until your seatbelt stops you. Okay, so what do we notice about these two situations? Well, you are always moving in the direction opposite of acceleration. Up here, you're accelerating to the right. Over here, the acceleration's to the left. You feel like you're going backwards. Here, you feel like you're going forwards. So the direction that you feel like you're moving is always opposite the direction of acceleration. So now you're traveling along and you're going at a constant velocity, but you're going around a curve. Okay? Well, what do you feel as you go around the curve? Well, you feel like you're going to be going outward. Okay? So if you feel like you're going to be going outward, then the centripetal acceleration must be directed inward. Okay? To follow this pattern. So let's go ahead and look at some more things about centripetal acceleration. All right? Centripetal acceleration is the acceleration of a moving object that is directed towards the center of a circular path. Okay? The object may be moving at a constant speed, but changing the direction, and hence the velocity is changing. Okay? It is a vector. The direction is always towards the center. Okay? It is the centripetal force. Okay? Centripetal means center seeking, so it kind of tells you right there which direction it's going. Okay? The symbol is A sub c. The units are meters per second squared, and we've got two equations. The centripetal acceleration equals the tangential velocity squared divided by the radius, or the centripetal acceleration equals the angular velocity squared divided times the radius. Okay? Here we must be in radians. Okay? It's because we simply derived the second equation from the first. Okay, and we used one of the equations where we need to be in radians to do so. Okay, one last thing to remember is A sub c is for direction, and the tangential acceleration is to describe a speeding up or slowing down.